Hi, I thought I'd add a few little fun things for this week. So, a few days ago, we went to a place called the Limehouse Conservation Area in Ontario, and it's got some kind of cool features I thought were kind of fun to sort of point out. So, here you can see that we have this whole area. I will adjust which pen I've got here. And so, we've got you can see this ridge line where there's ground to walk on, and in between, several feet distance, or at least a meter, maybe 2 meters wide, there's a great big crack. And this is maybe about 20 feet down. I'm guessing about 3 meters. I'm still kind of thinking feet, even though we're very metric in Canada. And so this whole area you can get down into. There's a ladder you can climb down and walk around and touch the damp rocks. This is limestone. And it's kind of cool. It's kind of like you'd be walking in caves without a roof on top. So it's kind of neat terrain to walk around. You got to watch out if you're walking on this upper part, of course. And most of the area is sort of roped off to watch out for your footing, but not all of it, as you can see. So it's kind of fun area. So limestone was used up until about 1900. It's still used today to some degree, but the process up until about 1900 is that lime putty was used in construction. So it was used as lime putty. There was also mortar that was made, sort of like a cement type substance. And if you have a look at this picture, you have a gunpowder storage area. And what this was used for is, of course, storing gunpowder. And it was in a depression. So usually they'd store the gunpowder in like a hollowed out part from the land. And that way, if for some reason gunpowder can be fairly unstable, if it were to explode, you've got it sort of contained with a bit of land around it. So that was the idea behind it. What did they use gunpowder for? They would break up the limestone rock into fairly large boulders that could be then carried away and turned into this lime putty and mortar. So this was kind of the setup. And here, this particular picture, you can see again that you can go deep down inside. There's all kinds of pockets where the limestone is no longer, due to some of it would have been dissolved and some of it would have been from this blowing up of limestone to use to turn into lime putty and mortar. So what would they do with this limestone? Well, they would actually take these broken up rocks of limestone and break them up into much smaller pieces, and they would bake it inside a really large kiln that was super hot, of course, and this would alter the material. And there was wood, coal, coke, different things used as a fuel to be able to have this great big kiln to heat up the limestone rock. And then after this limestone rock was heated, there was a time when this limestone would be soaked in water, and sand would be added at times as well to make this lovely limestone putty and also to make mortar type formats. So this was a big process used in order to make construction. So what is happening during this process of making mortar and making a lime putty? Well, the interesting part is there's a two-step process, and it's kind of backwards thinking about it, but anyway. So calcium carbonate is limestone. And when you heat it, you will release carbon dioxide gas into the atmosphere, and you will end up with calcium oxide. And that's what happens in the kiln. And then the next process seems kind of backwards to think about, but you take your calcium oxide and you soak it in water. And during the process, carbon dioxide will also be absorbed from the atmosphere. So that will come into play again. And what you end up with is back to kind of what you had before, calcium carbonate, only it's way stronger, and you will have some calcium hydroxide. Oh, and I failed to add, you will have some sand in there, some sand and aggregate. That will be mixed in. So mixed sand. So that'll be in amongst everything too. That'll make it way more structural. And you can even see whether this all balances, because we've done a little bit of balancing in the past. So our first one is nice and straightforward. You can see one calcium and one calcium, and you can see a carbon and a carbon, and you have 3 oxygens and 3 oxygens. So that is easy. Now, when we go to the adding the water part to your limestone setup, you had limestone turns into calcium oxide, sorry, and then the calcium oxide turns back into calcium carbonate with some calcium hydroxide and some sand mixed in. So let's see if we can balance this. So what do we have here for calcium? Oh, we got 1. How many do we have over here? 2. Oh, we're going to have to put a 2 here. Okay, now we got 2 and we got 2. That's good. What else do we have? Hydrogen. We have 2 of them. And we have 2 chunks of hydrogen and oxygen combined. So you have 2 hydrogens. Okay, and what about our carbon? We have 1, and we don't have any carbon. Oh, we have our carbon all mixed where I was seeing my carbon. So we have 1 and 1. That's fantastic. And a big test to see whether we're all balanced. So oxygen, what do we have? We have 2 molecules worth of oxygen. And then we have 1. And then we have 2. So we have 5. And then what do we have on the other side? 3 and 2. So 5. So we started off with calcium carbonate as limestone. We heated it up in the kiln. We released carbon dioxide and ended up with calcium oxide. And then you have calcium oxide. You soak it in water, and carbon dioxide that's in the atmosphere will be combining with it. You mix it in with some sand, and you will have calcium carbonate reformed. Limestone again, but it'll be mixed in with some calcium hydroxide and some sand aggregate. And so here is how you can play with thinking about what happens with limestone and how it's processed. And we get to see a little bit of what happens that way at the Limehouse Conservation Area.